So in these notes today, guys, we're going to go over translations and reflections. So first of all, translation or slide is a rigid transformation in which all the points of the figure move the same distance and direction. So translations can be written in one of three forms: words, coordinate, and vector, okay? So when we talk about translations in the coordinate plane, if we do a horizontal translation, notice if we move this from P to P prime here, that we are moving it the distance of A. So this would be x plus a, and y did not change because it did not change vertically, it only changed horizontally. So our xy would change to x plus a comma y. All right, so over here, if we go from P to P prime, notice this time it only changed vertically, okay? So it changed by the height of B. So it went from this point down here up. You see that? Which is why it's a plus. Now if it had gone down, it would be minus. So this is xy then transitioned to x equals y plus b because it went up by the length of b. Then over here it says, let me go back here. So this vector for this, because there is no change in y, it is a comma 0, and it's in these brackets. Y'all see those brackets right there? Over here, because there was no change in the x, but there is a change in the y, this is going to be 0 comma b. This third one over here is a general translation. Okay, so this one changed both vertically and horizontally. So notice here that we go from P, which is xy, to P prime, which moved over to the right and up. So this is x plus a and y plus b. So that's how it changed. So xy changes to x plus a, comma, y plus b. And notice our vector up here. It is the change in x, that's our first position here, and our change in y there. So it went to the right by a, and it went up by b. Okay, so this is just a reiteration of what we learned the other day about reflections, rotations, translations. Not sure why this is here, but we are actually doing this one over here, translations, okay? So our first one is examples that identify the transformations shown in words, coordinate form, and vector form, okay? So we're going to show this in 3 different ways. So what we're going to talk about first is we're just going to take one of these points. We're going to start with the point that is, we're going to put these in alphabetical order. So it's Q, R, S, P, right? So we're going to look at this Q point right here, okay? So what I want you guys to notice is if we go from Q to Q prime, do you notice that it did not move up or down? It only moved left. Okay, so let's look at this. So we're going from Q, 1, 2, 3, 4, left. So the first thing we're going to write is that it translated 4 units left. Okay? Now, we're going to write that as a coordinate in coordinate form. So we're going to write x comma y changes to, did it move left or right? It moved left by 4, right? So we're going to write this as x minus 4, and we didn't change up or down, did we? So we're not doing anything to y. All right, then our third item here that we're supposed to do is to write it in vector form. So once again, we're looking at the change in x. So the change in x is we went minus 4, right? Was there any change in y? No. So we're going to say that this is 0. So that's how we write it in vector form. Okay? Let's do another one. Okay? So now again, we only have to look at one point, guys. We could look at x, we could look at y, we could look at z. So let's just look at y on this next one, okay? So on this one, so here's our y and there's our y prime. So notice on this one, we're moving 1 to the right, 1 to the right, and 1, 2 up. Do you see that? Does everybody see that? So our first point here is we're going to translate 1 right and 2 up. Okay. Now let's talk about how we would write this in coordinate form. Okay, so in coordinate form, we're going to do our x and our y, and right means positive and up means positive, right? So we're going to say x changed by +1 and y changed by +2. Now, if it was down, we would be putting minuses, okay? If it was left, we would be putting minus. All right, now, the last thing is to write it in vector form. So that's our third point here. So our vector form is going to be what? Okay, hint, hint. Notice right here, 1 and 2. So that's going to be our vector form right there, y'all. That 1, 2. And it is the change in x and the change in y. So on this you try, I'd like you guys to go ahead and do these and then come back to me when you're done and we'll check them. Okay, so I'm going to start with point, we could do F or we could do G or H or I, but I'm going to have to go ahead and start with F, okay? So again, it says identify it in words, in vector form, and in coordinate form. We're just going to keep it in the same order we did last time. So we're going to do our words first, okay? So let's look at G right here. No, actually, let's look at F. So F, we're going 1, 2, 3, 4. Remember, we're going from F to F prime, right? 5. So that's 5 units left. And this is translation, right? Translation. 5 units left. And then what? 1, 2, 2, 3, 4. 4 units up. Right? Okay, remember, we're always going from F to F prime, from something that doesn't have the tick mark to something that does. Okay, so then we're going to talk about the coordinate form. So we're going to do our xy, x, comma, y. It changes to what? So if it's 5 left and 4 up, doesn't that 5 left mean it's going to be at x minus 5? And this is going to be y plus 4, okay? Then remember, we're taking those two values and we're putting them in a vector, okay? That's just our vector. So our vector is going to be -5, 4. You guys getting it? Okay. So let's do number 2 over here. So on this one, notice we go from F to F prime. What happened? This one is just 1 unit up, isn't it? So for number 1, we're going to translate 1 unit up, right? Okay, so now what does that look like in our coordinate form? We're going to say x, comma, y. That transforms to be, x didn't change at all, did it? Because it didn't move left to right. But what happened to the y? It went 1 up, right? Okay. Now we're going to talk about our vector form, okay? So if the x didn't change at all, isn't that going to be 0 here? And if the y did change up 1, are we going to put the 1 there? Okay, you guys getting it? All right. All right, here's our third example. So this time it says translate triangle STU using the following rule. We're going to add 2 to the x, and we're going to subtract 1 to the y. Then we're going to draw the triangle STU prime. So first of all, let's find these points. So this point right here, S, is what? 0, -2. Okay. What about our T? This one is -1, 3. And then what is our U? -2, 1, right? -2, 1. Okay, so now when we talk about doing this, we're going to take the x values and we're going to add 2 to them. So I'm going to go ahead and show you how this is. We're going to do 0 plus 2, comma, -2 minus 1. So you guys see what I did? I took this right up here and I applied it to my x and my y, okay? So when I get the final result, it's going to be what? That's what we're going to put down here for our s prime. So that's going to be what? 2, -3, isn't it? It is. Okay, so now let's do the same thing with this one. So we're going to go -1 plus 2, 3 minus 1. Okay, remember that's what's going down here for our t prime. So what is -1 plus 2? Isn't that 1? And what is 3 minus 1? That's 2, right? So that one is 1, 2. And then this next one, again, we're going to go -1 minus 2. Sorry, I'll put that backwards, y'all. -2 plus 2. -2 plus 2, 1 minus 1. Oh, well, that's just 0, 0, isn't it, y'all? 0, 0. Okay, now we're going to plot these points. And I'm actually going to plot them in red because the other one's blue. Okay, so we're going to go 2, 3, 2, negative 3. Sorry, 2 to the right, negative 3 down here. So that's our, my pen is just messing with me, y'all. I don't know what's going on with it, but it's not writing. So 2, negative 3 is right there. Okay, so that's our new S prime. Then we've got T prime, which is 1, 2, 1, 2 up here. T prime. And then we've got U prime, which is 0, 0. That's at the vertex now, isn't it? U prime. Okay, so now we're going to draw this thing. And you can verify this, right, by looking at these points. Did they move 2 to the right and 1 down? Did every point move 2 to the right? So let's look at U. 1, 2, 1 down, right? 1, 2, 1 down, right? 1, 2, 1 down. Now see, the truth is you could have done this either way. We could have done it manually like we did up here mathematically, or we could have done it like we did on the graph just a second ago. So it doesn't matter which way you do it. You could do it either way, okay? So this next one, we're going to go ahead and find these points A, B, C, D. And I'm going to show you guys after you're done. You guys go ahead and do this one. And when you're done, I'm going to show you how to do it manually like I did the second one, the one we just did the second time around, okay? All right, so A is 2, 4. You know what? I'm going to make this blue like it is, and I'll make the second one red. So this one's 2, 4. B is 2, 1. C is 3, 1. And D is, what, 3, 4. Okay, so now watch. This time it says that we're going, and when this time we have a vector. You guys see that? So that means we're going to go x minus 1, and we're just going to leave y what it is, okay? Because there's a change to 0. So on this one, we're going to move every x value to the left 1, right? So here's my new A. So that's my A prime. We're going to move the D1 over. So this is now my D prime. We're going to move B to the left. So this is B prime. We're going to move C to the left. So that's C prime. So this is my new shape. Now notice how I did it manually. So I moved everything 1 left, okay? So now what is our A prime? It's going to be 1, 4, right? So our B prime is going to be 1, 1. Whoops. Our C prime is going to be 2, 1. And our D prime is going to be 2, 4. Does that make sense to everybody? So the next concept we're going to talk about are reflections or flips. This is a rigid transformation across a line called the line of reflection. Each point and its image are the same distance from the line of reflection, okay? So we've got a reflection across the x-axis. The way I remember this is if it's a reflection across the x, then the y changes. So notice here in our coordinate notation, it's xy changes to x comma negative y. When we do a reflection across the y-axis, the x changes. So notice here, this is the y-axis, right? So we are going xy. This time it's negative x comma y. Then we have across the line y equals x. Okay, so when we do this, they're going to flip. Y becomes x and x becomes y. So our xy becomes yx. Now the only other one that we don't have on here is a reflection across the line. Y'all might want to write this down. Y equals negative x. And when we do that, the transformation is x comma y translates, or transforms, I should say, to negative y comma negative x. So they both change two negatives and they flip. Okay, that's what happens when you, because that line, by the way, let me show you what it would look like, y'all. That line would be this line right here. Okay, that's what it would be. So that's the line y equals negative x. Okay, that's that blue line. Okay, so now here's our examples. Identify the type of reflection and write the rule being applied. So what do you think is happening here, y'all? So let's look at, we could compare our points, right? So we could compare them, or we can just look and see what we think is happening. So we've got B and B and A and A and okay, so remember our trick the other day? So we go B to B, A to A, C to C, right? Y'all see that? Those are all parallel, but are they all the same length? So this is a reflection. Remember I said that, right? So again, do you notice where would those lines be bisected by then? You're right. Yep, it would be a line like this, right? Like that one I just talked about, right? So this is going to be a reflection, and this is the line across the line y equals negative x. And our notation would be x comma y becomes what? Negative y comma negative x. We just talked about this one, y'all, just a second ago, okay? All right, so now let's look at number 5. This says identify the type of reflection, right? The rule being applied. So once again, we can connect these H, I, J, right? They're all being bisected. See this right here? Those right there, these right here. So it's being bisected how? By the what line? What axis, y'all? So this one's a reflection over what? Over the x-axis, right? Now remember I said if you reflect over the x-axis, what changes? The y value, right? So when we write our error notation, okay, this is going to be what changes. So we reflected over x, so it's the y that's going to change. So this is going to be x comma negative y. And recall that when we reflect over the y-axis, the x changes, okay? All right, so let's see if you guys can do, oh, let's do this example together. Okay, so this says reflect rectangle ABCD across line y equals negative x. So that is the line y equals negative x. So let's go back and look at that rule. What happens when it's the line y equals negative x? What is our actual rule? So we go x, y does what? Is it going to be negative y comma negative x? Isn't that going to be our rule? It is. Okay. So now let's go ahead and label A, B, C, and D. So this is 2 comma 1. B is going to be 5 comma 1. C is going to be 5, 6. And then D is going to be 2, 6, right? Okay. Now, look what's happening up here. We're going to flip them and change the signs of both of them. Whenever there's a negative out front, we're always going to change the sign of what it is, okay? So now let's go ahead and do that. So that means we're going to go 1 comma 2, and then we're going to negate them both. This one's going to be 1 comma 5, and then we're going to negate them both. And then we've got 6 comma 5. We're going to make both of those negative. And then 6 comma 2, again, make both of these negative. Okay, then we're going to plot this thing just to see if it turns out the way it's supposed to be, okay? So, negative 1, negative 2. Negative 1, negative 2 right there. That's going to be our A prime. Then we've got negative 1, negative 5 right there. That's B prime. Then we've got negative 6, negative 5, negative 6, negative 5 right there. That's our C prime. And then we've got D prime, which is negative 6, negative 2. Negative 6, negative 2 right there. That's D prime. So we can connect all these points and we get this shape A prime, B prime, C prime, D prime. Now, when you guys look at this shape up here and the shape down here, they don't look the same, do they? But notice 1, 2, 3, 4, 5 high. And this one's 1, 2, 3, 4, 5 wide. And this one's 1, 2, 3 wide, and this one's 1, 2, 3 tall, okay? So they really are the same shape, but it's because you are flipping the x and y, okay? So that's why it's no longer oriented the same way, because it's flipping over that line, okay? So it is correct. All right, let's see if you guys can do this. You try and come back to me when you're done. All right, so on this one, J is negative 6, 2. K is, what is that? Negative 4, 6. And then L is negative 3, 3. and then m is -5, -1. Okay, so now this one says we're reflecting across the x-axis. So if you remember, what I said was, when we do this, we're going to take our x, y, we're reflecting across the x, then we're going to change the y. If we're reflecting across the y, we're going to change the x, right? So that means this is going to be -x, y, because we're reflecting over the y axis, right? So that means all we're doing for this one is changing the sign of our x value. Okay, that's all we're doing. So let's go ahead and write this here. So this is going to be 6, 2. This one's going to be 4, 6. This one's going to be 3, 3. Again, we're just changing the sign. This one's going to be 5, -1. Okay? So now we're going to plot those points, and we're going to see where it ends up. So 6, 2 is right there. That's going to be our new j prime, right? Then we got k prime, which is 4, 6. Right there. Then we got our L prime, which is 3, 3. Right there. And then we've got our M prime, which is 5, -1. And we're going to connect these, just like we did before. Now, how can we verify that this is right? Y'all remember? We can connect these dots, right? We can connect L to L prime, and then we're looking if these 1, 2, 3, right? 1, 2, 3. Is it being bisected? Sure is. Okay. You could do that with all those vertices just to double check and make sure your points are right.